The moon may be our nearest neighbor in space, but there's a lot we still don't know about it, such as where did it come from? One theory is that the moon resulted from an asteroid the size of Mars colliding with the Earth, flinging vaporized rock and debris into space, some of which went into orbit around the Earth and solidified to make the moon.
After the Apollo missions, people for a while really felt they knew all there was to know about the moon. They'd brought back 1/3 of a ton of moon dust, and they'd analysed it, and they'd come up with theories of how the moon was formed. It's only quite recently, in the last decade, that people have suddenly realised all the unanswered questions that are still out there, and the really big one is still where the Earth and the moon came from.
Tranquility Base here. The Eagle has landed.
The Apollo astronauts brought back samples from the near-side equatorial region of the moon. The most interesting regions, the far side, the poles and the mountains, weren't visited at all, and there's still much to learn. Smart-1, a lightweight probe of just 1 meter across, was launched in 2003 as the first of the European Space Agency's small missions for advanced research and technology.
This is the first European mission to the moon, and it's also the first European small-scale mission. Usually with space missions we're used to them taking tens of years and thousands of people. This is a mission that's really done by a small group of people, both here at the Rutherford Laboratory and in the whole of ESA. And we just worked like crazy for 2 years and got it built. It's a new way of doing things and much more efficient, we think.
The mission has already tested new solar electric propulsion, where solar panels provide electricity to shoot out ionized propellant gas at high speed, producing a continuous tiny thrust. The ion engine is very fuel efficient, helping the probe to travel 3 times as far as a chemical engine for the same weight of fuel. And it's faster over long distances. With the instruments on board, Smart-1 is now looking at the moon from orbit and developing an understanding of the geology of the lunar surface without having to land. It's mapping the chemical composition of the moon and even searching for signs of frozen water near the poles. One of the main instruments on board Smart-1 is DKIX, an X-ray spectrometer designed and built at the Rutherford Appleton Laboratory near Oxford.
The DKIX X-ray spectrometer is designed to look down at the surface of the moon and tell you what it's made of. When the sun shines on the moon in X-rays, the moon glows in X-rays. And if you can detect those X-ray colours, you can tell exactly what the moon is made of.
Globally, this information will help scientists draw up 3D models and produce the first comprehensive inventory of key chemicals in the lunar surface. This will help to establish whether the moon and the Earth have the same origin.
The other instruments for looking at the moon are the infrared spectrometer and the camera. And what these are designed to do is to look down into the dark craters on the north and south pole of the moon to see if there's ice there. There's a lot of evidence that there may be ice there, and if there is, of course, that makes it a great place to do a lunar base.